All of mathematics requires attention to precision, and Standard 6 focuses on the need for students to attend to precision. Precision in mathematics requires students to be careful and specific about units of measure, how they label axes on graphs and charts, and generally how they communicate about mathematics. Students who are attending to precision calculate accurately and efficiently, expressing numerical answers with a degree of precision appropriate for the problem and context. They also are precise when they communicate mathematical understandings to others. They use clear definitions in discussion and have precise understandings of the meanings of the symbols they use. So what might Standard 6 look like for a student with significant cognitive disabilities? Think about how we use the word same when it really doesn't apply. We talk about 4 plus 4 is the same as 7 plus 1. In fact, they are equal in quantity or amount, the answers are the same, but the problems are very different. Here we have the equation written. 4 plus 4 equals 7 plus 1. That is true. 4 plus 4 and 7 plus 1 do equal the same quantity, but they are not the same. Let's return to the example we discussed earlier. If you walk into a store and buy an $8 box of chocolates with a friend, and you spend $4 and your friend spends $4, you have each paid an equal amount for that $8 box of candy, and you should share it equally. However, if you walk in with the same friend to buy the same box of chocolates, and you spend $7 and your friend spends $1, then you have not paid an equal amount for the box, and should not be shared equally. 4 plus 4 and 7 plus 1 both allowed you to purchase the same box of chocolates, but the way you secured that box was not equal. Here is another example. 1 equals 1 cubed. In fact, 1 does equal 1 cubed in quantity. Think about what this would look like in a visual form. You would have one one-dimensional square and one three-dimensional box. They are equal in quantity, but they are not the same. They are two different things. In this example, an elephant and two trucks could be weighed on a balance scale. I can say that the weight of two trucks is equal to the weight of one elephant, but clearly two trucks are not the same as an elephant. Being precise about the unit and the language you use is absolutely critical. The next standard is Standard 7. It states that students should look for and make use of structure. Mathematically proficient students who make use of structure pay close attention to discern patterns or structures that exist within the problem context. They recognize the significance of particular lines in determining geometric figures. They are able to step back and look at a problem holistically, for an overview while maintaining the ability to shift perspectives. They can also see complicated things such as some algebraic expressions, as well as look for functions in the everyday world. Related to Standard 7 is Standard 8. It states that students should look for and express regularity in mathematical reasoning. For example, mathematically proficient students who notice and express regularity in mathematical reasoning notice when calculations are repeated. They look for both general methods and shortcuts within the problem situation. As they work to solve a problem, they maintain oversight of the entire process while attending to the small details needed to formulate a solution. Looking once again at McCallum's model, you see that Standards 7 and 8 are grouped together in the single category, seeing structure and generalizing. What might this look like in a classroom for students with significant cognitive disabilities? Consider multiplication. It is often a difficult concept for students with significant cognitive disabilities, and many people think that you don't teach multiplication, you just have to memorize it. Perhaps it is this focus on memorizing multiplication facts that makes so many students find it difficult. If instead of focusing on memorization, we recognize that multiplication is only repeated addition, it becomes easier to understand how multiplication can be taught. It also helps students to access the solutions much more quickly. Look at this example. It shows that multiplication of 6 times 7 is nothing more than 6 times 5 plus 6 times 2. Yet this is only one way to set up this solution. You could also multiply 6 times 5, which gives you 30, and add it to 6 times 2, which is 12. This is another way to get to the solution of 42. This is often much more accessible for students because we teach students the 2s, 5s, and 10s on the multiplication chart, and because those are the numbers we most often use when skip counting. We still have not exhausted the possibilities for solving 6 times 7. Another way is to start with 6 times 6 and add 6 times 1. There are multiple and various ways to solve this particular problem, just as there are multiple ways to solve almost any mathematical problem. One important way we teach students to see structure and generalize is to teach multiple practices in a single lesson and tie them together instead of teaching them in a disconnected way. Without this integrated approach, there will be no structure for students to see and generalize. Thank you for the opportunity to share with you the standards of mathematical practice that the Common Core was built around. In future modules, we'll focus more on specific teaching strategies that will support students with significant cognitive disabilities in working towards these standards. Thank you for your participation. To learn more about the Dynamic Learning Maps Alternate Assessment Consortium and the Alternate Assessment System, please go to www.dynamiclearningmaps.org.